Okay, so today we're going to talk about finding restricted values and simplifying rational expressions, and hopefully this doesn't seem brand new to you. So for part one, we're going to focus first on finding restricted values. So we did this before when we were back in the beginning part of Algebra 2 when we were finding domain restrictions. So whenever you're finding a restricted value, that's when a part of your domain is going to be undefined. So for instance, for example 1, it says consider the rational function given by f of x, and it asks you two things. For what x values, or for what value of x is this function undefined? So that's the first one. And then the second one says, why is it undefined at this value? Move it over. Okay, so those are the two things we're finding. Anytime something is undefined, if you think back to when we were looking at domain restrictions, there were three main restrictions. We have whenever you have fractions, again, your denominator cannot equal 0. Whenever you have radicals, square root or even roots, you don't want any negatives underneath. And for the last one, which was a combination of fractions and radicals, you have to kind of consider both. So you don't want, for instance, for this question, zeros in your denominator, and you also want your radical to be a positive number underneath. You don't want it to be negative. So for this page, we're going to focus on making sure that this fraction is not undefined. So whenever it's undefined, that's when you have a problem. So the first thing we're going to do is we're going to take that denominator. Oh, let me actually write it this way. Let's do set the denominator equal to 0, and you're going to solve. So whenever you're trying to find what is undefined in your function, f of x, you're going to take that denominator, make it equal 0, and solve. So we're going to take the denominator, which is x minus 3, set it equal to 0, and solve. How would you move the 3? Add it. So x would equal 3. Mia, what does that mean if x equals 3? When x equals 3, the denominator is 0. Let's double check that. So for my second part, we're going to take f of 3, and we're going to set it equal to 3 plus 6 over 3 minus 3. I just want to make sure that what Mia said is correct. So 3 plus 6 is 9. 3 minus 3 is 0. That's where the error is. And whenever you get a problem that has 0 in your denominator, this is when you will get an answer that is undefined. And that's what I want to avoid. So step 2 on the problem said, why is it undefined at this value? Well, we just proved it here. Whenever it's undefined at this value, that means you have 0 in your denominator. So this is step 2. That was undefined for that denominator. You can't divide anything by 0. So that kind of answers question 2. And let's go ahead and look at the next question. Example 2. So this one says for all values of x, or find all values of x for which the rational function h of x is undefined. Lorraine, what am I going to do if I want to determine when it's undefined? What do I need to do? We just talked about it. Set the denominator equal to 0. So let me zoom in, and I'm going to recopy that denominator. So we're going to have 2x squared plus 11x minus 6, and we're going to set that equal to 0. How would I solve this, Lorraine? What would I have to do? I have to factor it. So I'm going to make my little x chart, and I'm going to find two numbers that multiply to negative 12 but add up to positive 11. Lorraine, what two numbers can you use? 12 and negative 1. Good. When you multiply both of them, you'll get negative 12. When you add them, you'll get 11. Whenever I write out my answer, can I just write it as x plus 12 and x minus 1? Why not, Lorraine? Okay, so this 2? It's not 1. What is this called? It begins with an L. It's your leading coefficient. So it's the number that's in front of your highest exponent. So this is your leading coefficient, guys. So when your leading coefficient is something other than 1, you have to factor by grouping. So we're going to rewrite 2x squared. And instead of 11x, I'm going to write it as a combination of 12 and negative 1. Because when you do 12 minus 1, you'll get 11. So plus 12x minus 1x minus 6. I'm going to factor by grouping. I'm going to group the first two terms and the last two terms. Tristan, in the first group, what can I factor out? 2x, and what's left in parentheses? Be careful with the second one. What can you factor out here? -1, good. Since this negative is in the first term in that second group, so not first term, but it's the first sign in that second group, you want to take this negative out. Anytime it's negative, I don't care what the number is, take that negative out first. And then what's left in parentheses? Did I do it right? How do you know? Both of these binomials are what? They're equal, they're the same. So we're going to take one of those x plus 6's, just write it once, that's one of your answers. The other answer comes from your GCF, so from the 2x minus 1. It's factored. So now I just need to see what are the values of x that will equal 0. So by the zero product property, we're going to take both of those binomials and set them equal to 0. Once you solve this, you'll see what values x, or the function of x, will equal an undefined answer. So we're going to subtract 6 for the first one. X will equal -6. And then we'll add 1 to each side. So 2x will equal 1. We'll divide both sides by 2. So if I was to take both of these x's and plug them back in, I don't have to do this for every question. I just showed you for the first one to give you an idea of what should happen. For both of these answers, when you plug in to h of x, sorry, I thought this was an f of x, but this is an h of x function. So for h of x, when you plug it in, you should get 0 in your denominator when you use this one first and then this one after, or whatever order. So I'm just going to write this out. So I'm going to write out the x equal 1/2 and x equals 6 solutions will be undefined for the function h of x. Is it h equal -6? Yes, h equals -6. I may make that a negative. Thank you. I'm purposely writing this out, guys, because I know you're going to forget it. By the time you're studying for your test, you're going to forget why we found x equals -6 and x equals 1/2 and why it was relevant. So all of the stuff that I'm writing out, write it out. This is the most you have to write for my class. All right, let's look at example 3. For example 3, this one says, state the restrictions for each rational expression. Well, there's just one, and that's x plus 2 over 5. If you're looking at this, the first thing I need to look at is my denominator. So I'm going to zoom in a bit. In this denominator, I have a 5. Nicholas, will this denominator ever equal 0? No. Why? Because it's not, well, not just because it's not 0. What do you not have down here? You have a 5. What do you not have? You don't have an x. You don't have a variable. Anytime you have just a number, so this doesn't just apply for 5, it applies for any just number that's in the denominator. If you have just a number in your denominator, it's not going to affect your answer because you could plug in any x you want here. It's never going to affect this denominator. However, if you were to have, like, for instance, a 5x, would you have an issue there? Yeah, because you could potentially have 0 in your denominator. So I'm just going to make that note. There are no restrictions for this problem because, again, I'm writing this because I know you'll forget it by the time you're studying for your test. 5 is just a number. When your answer is just a number, it's not influenced by the x's that are being plugged in. When you just have a number, it's not going to affect your final answer. So every answer you get will be be defined. It won't be undefined. All right, so that was part 1. So part 1 was just helping you refresh your memory about finding restricted or undefined values. The next part is going to talk about part 2. Okay, so part 2 asks you to simplify rational expressions. It looks disgusting, but it's really easy. I'm going to put this little note at the top of the page, and if you have a nice, pretty, like, marker or pen that you want to use to cancel some things, get it out, and I'm going to probably have you do that over the next several days as we go through this unit. So if you have a nice, pretty marker or pen that you want to use to cancel some things out, take out some vengeance, go ahead and take that out. All right, so at the top of my page, I'm just going to put just a little bit of a step for part 2. The step is, I want you to factor, then look for terms. I'm going to put term/terms that cancel. That's pretty much what it means to simplify a rational expression. What you're trying to do is factor first and then look for a term or terms that can cancel. So I'm going to look at the first example with you guys. So for the first one, this one is 2x minus 2 over 6x squared plus 6x minus 12. Elias, can I factor anything in my numerator? A 2. I can factor out a 2. Remember, guys, the first thing you guys learned how to do when you were factoring was doing just this, factoring out a GCF, which is a greatest common factor. So if you can factor out a greatest common factor, do that. Elias, I know I could probably do the big X factor, like where I actually draw the little X out and find 2 things that multiply and 2 things that add. But can I factor out a GCF first? 6. I can factor out a 6. What does that leave in parentheses? Perfect. Once you have that factored, I'm looking at this 2 and 6 and thinking, hey, I can cancel this. But before you start canceling or reducing, let's take what's in the parentheses here and let's actually factor it. Hopefully you are using kind of like the same format that I am, because on the left, underneath my problem, I'm actually going to show my work for factoring. So I'm going to make my little X chart, and I'm going to find 2 numbers from this parentheses that multiply to -2 and add up to +1. Elias, what 2 numbers can I use? 2 and -1. So when you multiply them, we'll get -2. When you add them, you'll get +1. Elias, can I write out my denominator down here as just the 6 with the x plus 2 and x minus 1? Could I put it like that, or do I need to factor by grouping? I could put it like that. Your leading coefficient in front of x squared is just a +1. When that happens, you can just write out both of your binomials. So I'm going to recopy x minus 1, and down in the denominator, we'll have x plus 2, x minus 1. Nicholas, take a look at what Elias just wrote out. Can I cancel anything? Oh, I can't cancel those. I could reduce them, so I can draw a little line through it. I could reduce them. What is 2 over 6 reduced to? 1/3, so I'm going to put 1 over 3. Can I cancel anything else? X minus 1s. That's why you have your fancy pen. You can cancel those out. Take out your aggression for the day on that. So we're going to rewrite what we have. So double check. Nicholas, is there anything else I can cancel or reduce? Okay, so let's rewrite it, because maybe we can and we just don't see it. In the numerator, the only thing we have left is a 1. Nicholas helped us simplify it, so we just have a 1. In the denominator, we only have a 3 and an x plus 2. Not just Nicholas, all of you guys, take a look at what I have. Can I cancel or simplify that any further? No, that's it. With that 1 in the numerator, we can't do anything. This would be your answer. So on tests and quizzes, you can leave your answer just like this. If you want to distribute that 3, you can, but it's just an extra step that you really don't need to do. Give me a nod or shake. Is this okay? All right, let's look at the next one. So I'm going to look right on the right-hand side at question number 4. And we're going to simplify this one. Just like I did before, I'm going to save the space that's underneath your problem for my work in case I need to factor anything. So take a second to look at the numerator. Emma, can I factor that? How? Say it one more time, but a little louder. It's difference of squares. Remember this page that we did a while back when we were looking, I think right before polynomials? Yeah, this is the page she's talking about. So all of the factoring that we did on this page, I know you guys forgot about it. We've done difference of squares, we've done sum of cubes, and we've done difference of cubes. We've also done a couple of other things where we've actually had to factor where your exponents are higher than 2. All of the stuff that we did on this packet and others are going to show up again on these questions. So for your homework, make sure you start practicing those again. Okay, so you said this was a difference of squares for your numerator. What does that look like when you factor it? Perfect. And then for your denominator, Emma, can you factor anything there? Because that's not difference of squares. You can factor out the x. So x minus 5. Emma, can I cancel anything or reduce anything? All right, fancy pen, I'm going to cancel out my x minus 5s. Those are gone. And I'm left with, let me see what I have. I'm left with x plus 5 over x. Emma, I'm going to ask you a question. I hope you have the right answer. Can I cancel these? That sounds like a non-confident yes. What do you guys think? Help her out. Can you cancel these? No, why not, Andrea? Well, it does have a plus. It's just by itself. So there's two things that go with this. The reason why we cannot cancel this is because this addition is affecting this x. You cannot cancel something if it's being added or subtracted to another number. If instead, don't write this out, if it looked like this, you could totally cancel the x's. This x and this x. But since this x plus 5 literally has a 5 attached to it, you cannot cancel both of these. You cannot do it. That's the quickest way to lose points on a test or quiz. With that being said, this would be your final answer. You're done. Give me an outer shake. Does that make sense why we cannot cancel that? Emma, you okay with that? You're good? All right. Let's look at the next page. Look at number 5. I'm not going to go through every single question with you, but I will help you at least start off a couple. For question number 2, I think y'all could do this all by yourself. Go ahead and do question number 2. I'm going to give you guys about 3 minutes. All right. Zara, for question number 2, in the numerator, could you factor anything out from here? Okay. What can you factor out from the numerator? Because you have a 5r squared and a 20. Okay, so we're going to factor out a 5. That leaves r squared minus 4 in parentheses for your numerator. In the denominator, I don't have a GCF that I can factor out, so I'm just going to recopy r squared minus 4r minus 12. Okay, so I know for sure in the denominator, we're going to have to factor this using that x chart. So I'll make that little space over on the right hand or left hand side. In the numerator though, Zara, can I factor this any further? Into what? Mm-hmm. And then what's the other one? Nope, not r minus. There you go. That's a difference of squares, guys. R squared minus 4, you can take the square root of both of them. So that's a difference of squares. In the denominator, you should be able to factor this as well. So you're going to write out two numbers that will multiply to negative 12, but add up to negative 4. Maria, what did you get for this? Double check. They both multiply to 12. They both add up to 4, negative 4. That looks good. Can I just write both of my binomials out as r minus 6 and r plus 2? Okay, good. So r plus 6, just kidding, minus 6. And then r plus 2. Maria, can I cancel anything here? Fancy pen, those are gone. Can I cancel anything else? No, nothing else cancels. Does anything reduce and still stay there? No. Okay, so it looks like my only answer is going to be 5 parentheses r minus 2 over r minus 6. Remember, we've had this discussion. You cannot cancel the r's because you don't like how they're looking at you. You have to keep it just like it is. This would be your answer. If you want to distribute that 5 in your numerator, you're more than welcome to, but you don't have to. All right, I'm going to give you guys 2 more questions to do. And after those 2 questions, I'm going to add in 1 more question. So you can either add it in at the bottom of the page or the back of your page. All right, for question number 5, I'm going to start you off with this. You're going to finish it along with one other question that I choose in just a second. Okay, so for question number 5, just look at it. In your numerator, what does this look like? In your numerator, what does this look like? I'm hearing it, but whispered. Difference of squares. It does look like difference of squares. The issue is the x is second and the number is first. So what I would suggest doing, because I know that you guys will freak out on your tests and quizzes, I would suggest rewriting this as negative x squared plus 9. I'm just rearranging it. And then I'll recopy the 5x squared minus 14x minus 3. I know for sure we're going to have to simplify that denominator by factoring on the left, but in the numerator, this isn't really difference of squares anymore. It looks different. What could I do to make it look a little nicer? Factor out a what? Factor out a -1. When you do that, it's just going to switch the signs. This will be a positive x squared and then a -9 like you want. The denominator still needs to be factored like normal. So right now, I want you to start and finish question number 5. And then when you finish question number 5, you're going to do question 3 towards the bottom of the page. I'm going to give you guys about 4 minutes for question number 5, and then about 3 minutes for question number 3. For question 5, Elizabeth, when you factored it, so don't give me the final answer, but when you factored the numerator, what did that x squared minus 9 become? Okay, that's another difference of squares. And then in your denominator, what was the factored form for this? What was the factored answer? Okay, perfect. Especially for this one, guys, I already saw a couple people who messed this up a bit. When you're factoring this denominator, especially from the original, you cannot just rewrite the two binomials that you have as x minus 15 and x plus 1. Yes, they'll add up to -14, but your leading coefficient is something other than 1. So you can't just rewrite it as two binomials because you don't like it. From here, Elizabeth, what canceled? X minus 3. Those are gone. So I'm just going to write my final answer as, I'm going to scroll this down. We're going to make this negative x plus 3 over 5x plus 1. That should be your answer. That negative, please don't lose it. I saw some people last class period forget that negative from the first step down to the second. So be careful with that negative. All right, I'm going to give you guys about 2 or 3 more minutes. I want you to finish up question number 3. All right, for question 3, how am I supposed to factor the numerator? For the numerator? Grouping. We have to group the first 2 terms and the last 2 terms. So what you should have done was group the first 2 terms and the last 2 terms. That would have given you, I'm going to kind of group it at the bottom. It'll give you x squared parentheses x plus 2. And then for the second group, you're going to factor out a 3, which will leave you again with x plus 2. So both of these binomials are the same. That's what Desiree told us earlier. And then x squared plus 3 would be the other one. So in your numerator, you should have had x squared plus 3. I'm just putting that first. There's no reason why. X plus 2 over the denominator. What's the denominator? Difference of squares. So we're going to do x plus 2, x minus 2. Does anything cancel? X plus 2. Both of them are gone. When that happens, I'm going to write my final answer as x squared plus 3 over x minus 2. Is that my final answer? Can I simplify it any further, though? No. Even though this x squared plus 3 is in the numerator, a lot of students tell me, Ms. Tapi, I think you could do the difference of squares. 2 things. Is this an addition sign or a subtraction? Addition. I told you guys on your notes over sum and difference of cubes and difference of squares, that when you have, let's try that again. Oh, it's over here. Where is it? So I told you guys when we were looking at questions like this, whenever you have, I'm going to zoom in, a sum of squares doesn't exist. You can't do that. It's not mathematically possible, at least not to get any real numbers. You start messing with imaginary numbers if you start using sum of squares. So for the purposes of our lesson, anytime you have something that looks like this, yeah, sure, you could take the square root of it, but you can't solve it from there. So on my notes over here, This piece you can't simplify. The second reason why you can't simplify this any further is because what's the square root of 3? Is it a whole number or a decimal? It's a decimal. So all you would need to do is box this as your final answer. This would be your solution. There's one last question that I want to have you guys do. So at the bottom of the page, go ahead and get out just extra space, and I want you to add in this question number 7. X squared minus 4 over x squared minus 9. Michelle, how could I simplify x squared minus 4? What could I use? Difference of squares. Okay, so in the numerator, I can make this x plus 2, x minus 2. Perfect. Michelle, what about the denominator? Okay, so this will turn into x plus 3, x minus 3, since you said it's difference of squares. Chris, look at what I have in orange. Can I cancel anything? Not at all? Do you see any binomials that are the exact same? No, none of them are the same, guys. This isn't a trick question. It's actual what you might see. Whenever that happens, this is already simplified. You can't simplify it any further. So sometimes if it's multiple choice, you would just select this as an answer, or you could write out simplified. Hopefully I spelled that right. You would just write out simplified. Simplified on a free response style test or quiz is perfectly sufficient. You cannot simplify it any further. The original problem was already simplified. Give me a nod or shake. Does that make sense with what I just said? Okay. All right, so the rest of these questions on this packet are for you to practice, and make sure that you actually use this to help you study for your tests and quizzes.